let's take a look at adding and subtracting like fractions. To add or subtract fractions with the same denominator, write the sum or difference of the numerators over the denominator. Now that can sound a little bit difficult, but really we know what we're doing here. And so in English, what this is saying is that when you have two fractions, say, and I'll give you numbers for examples, if we have 7 over 11 plus 2 over 11, so it says to add or subtract fractions with the same denominator as we have here, 11, 11, write the sum or difference, sum if you're adding, difference if you're subtracting, so that's all those indicate, of the numerators over the denominator. So really, just write the sum of the numerators. So add the numerators and keep the denominator the same. So this is going to give me 9/11ths, and we're done. Let's say we had a subtraction problem. If I gave you 5 over 8 minus 3 over 8, so I'm subtracting, so here I'm finding the difference. All I have to do is keep my denominators the same and find the difference of the numerators. So basically subtract the numerators. We get 2/8 and keep the denominator constant. Now in all these problems, whether they say simplify or not, you always want to simplify. That's like a math rule, okay? They aren't going to write it from here on out all the time, but you want to make sure if you're left with something like 2/8, reduce it to 1/4. Now algebraically speaking, in all the general cases, it would look something like this. Algebra just implies for all situations, any A, any number B, any number C. If you have a situation like that, all you have to do is add A plus B over C. So it's like a code. It tells you like what to do in all situations for any number. And then same would go if we were subtracting. If we had A over C and we were subtracting B over C, so we have common denominators, all you do is subtract A minus B, but keep C the same. And now in both of these cases, the one requirement we have to add in is that C cannot be 0, and that should be understandable because we know that we can't have 0 in the denominator. If we do, things aren't going to work. We get an error. So that's the only thing that C can't be. C can be any other number in the world, but it can't be 0. Okay, so we've just written some algebraic expression rules to explain this. Good job, guys. Let's try adding some of these with common denominators. One night, 77/100ths of the moon's visible surface is illuminated. The next night, an additional 9/100ths is illuminated. What fraction of the moon's visible surface is illuminated on the second night? So 77/100ths plus 9/100ths, because it's an additional, we're going to add them. So 77 plus 9 is 86 over 100, and like I said before, you always want to reduce. So we get 43/50ths of the moon's surface is illuminated. Because it's a word problem, you do want to label, okay? The more you explain your answer in labeling, the more it's going to prove that you understand what the problem was saying, and it's also going to explain to other people reading it what your answer actually means. 43/50ths, what? Now we know of the moon's surface was illuminated. All right, let's try some without word problems and just subtract. So we have our common denominators. This negative, if I have negative 4/7 and it's right out on the front, we learned in class that that negative can go with the numerator or it can go with the denominator. It doesn't matter where you put it. For our sake, I'm going to put it in the numerator, and I don't have to scratch it out like that, but I can to help me remember. Negative 4/7 minus is really plus and negative, so again, I don't have to change that, but it might help me remember better. Negative 4/7 plus negative 2/7, I just add the numerators. Negative 4 plus negative 2 is negative 6/7. I'm done, can't be simplified. Letter B, 1/10 minus negative 3/10. Minus the negative is really plus the positive, so I keep my denominator constant and add 1 plus 3, which is 4. And we want to simplify, so we get 2/5, and that's that. Let's try a couple more practice together. We have here 3/8 plus 2/8. 3 plus 2 is 5. Keep my denominator constant. Can't simplify, so we are done. Negative 1/6 plus 5/6. Negative 1 plus 5 is positive 4/6, but that can be reduced to 2/3. Now in letter C, we have 3 terms, so we can either do the first 2, get an answer, add the third one. We can do them in any order, or we can just take them all at once. So I'm going to do it all at once. 2 plus negative 7 is negative 5. Negative 5 plus negative 4 is negative 9. So negative 9, and I keep my denominator same, over 15, and I can then reduce that. I get negative 3/5, because both are divisible by 3. Now in these examples we have mixed numbers, so my suggestion to you is always turn them into improper fractions. I know that sometimes you can just add the whole values and you can get an answer that way, But when we start introducing negatives and subtractions, unless you do it properly and take things away where you're supposed to and add them to whole values and things like that, there's a good chance you can make mistakes. So this way, if you turn them into improper fractions first, you're not going to make a mistake as long as you do all your calculations right. So to turn this, 5 and 5 ninths. 9 times 5 is 45 plus 5 is 50. So I have 50 ninths. 9 times 2 is 18 plus 7 is 25. So I have 25 ninths. I add my numerators and I get 75 ninths. But I want to turn that into a mixed number again. So I have to divide. I know my numerator goes on the inside. And when I divide, I get 8 and 3 ninths, which can be simplified. So my answer is 8 and 1/3. Letter B, negative 10 and 7/15. 15 times 10 is 150 plus 7. So I have negative 157 over 15. 15 times 5 is 75. 75 plus 8 is 83. If you ever don't know, please don't guess. Actually work it out. It's better to have that scratch work there than it is to just do it in your head and get it wrong. So both of these are negative, so I'm going to add them and keep my answer negative. And when I add them, I find that my answer is negative 240 over 15. Again, I want to turn that into a mixed number, and I do my scratch work here again. 15 goes into 90 6 times with 0 left over, so my answer is negative 16. All right, I'm going to work through these practice ones a little bit faster. Just follow along and hopefully, or try them yourself and see if you get the same answers and check back. So 2 and 3/4. 2 times 4 is 8, plus 3 is 11/4, plus this is going to give me 7/4. When I add them, I get 18/4, but to turn them back into a mixed number, I get 4 and 1/2. Letter B, I get negative 19/3 plus 11/3. When I add negative 19 plus 11, I get negative 8/3. Turned into a mixed number is negative 2 and 2/3. Letter C, it's going to be 21/5 minus 13/5. I'm going to subtract those. 21 minus 13 is 8/5, which is actually 1 and 3/5 is a mixed number. And letter D, negative 3 and 2/7 is negative 23/7. 6 and 3/7 is actually 45/7 because they're both negative, negative 23 and negative 45. I'm going to add them. When I do that, I get negative 68/7, which is actually negative 9 and 5/7. Because 9 times 7 is 63 and I have 5 left over. Okay? Alrighty, let's go to our last page. We're going to introduce some variables here. Now again, we have to have common denominators, so we don't want to change anything, which we already have, which is good. So the 20 stays constant. Now to add my numerators, I have to make sure they're common, or they're like terms. 3a plus 5a, those are like terms. So I can go ahead, combine them, and I'm good to go. And now I want to simplify. 8 over 20, 4 goes into both, so I get 2 over 5, and I keep my a constant. So still simplify even with variables. Letter B, my denominators are the same, so common, so I keep 3b there. Negative 8 minus negative 2 is really negative 8 plus 2, so I get negative 6. So now I want to simplify the numbers. Negative 6 over 3 is really negative 2 over 1, and my b is still in the denominator, so my final answer would be written as negative 2 over b. Two more. 3k plus 9k is 12k, and we know that our denominator stays the same, 28. And I want to simplify 12 over 28, and I divide both by 4, and I get 3/7, keeping k in the numerator. And letter B, I'm going to make that plus a negative. 4 plus negative 9 is negative 5 over 7y, and nothing can be simplified, so we are done. Last little thing before we're done, if you get an answer, all of these are proper fractions, but let's say our answer would have been negative 7y over 5. It would have been flipped. People say, would we have to turn that into a mixed number, negative 1 2/5 y? Where does the y go? Da, 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 da. The answer is, if you get an improper fraction as an answer with a variable, only with a variable, you can leave it just like that. Okay, refer to the directions to see how they want it done, but if it's this case, just simplify the numbers, but don't turn it into a mixed number. All right, you're done. Good job, guys.